This lesson is going to be looking at how to solve a basic two-step equation. Most things I do not necessarily care how you do it as long as you show me your work so I can follow it. However, equations are one of those things where I really ask that you please do it the way that I show you in class, because while today we are going to be looking at basic equations, we're going to be getting into equations that have a lot of steps and a lot of different pieces of work you have to show. And if your work is not organized, it will be very easy to make a mistake and lose track of what you have eliminated and what you have not. So again, please make sure you are following and completing the steps the same way we do in class when solving an equation. The first thing to look at with an equation is what is a solution. A solution is a value that produces a true statement when substituted in for the variable. So to check if something is a solution, like for the equation 3x plus 5 equals 20, in order to check if 5 is a solution, you have to substitute the 5 anytime that you see an x in that equation. So instead of 3 times x plus 5 equals 20, I would have 3 times 5 plus 5 equals 20. So then after I substituted, I'd have to follow the order of operations. So in 3 times 5 plus 5, I have multiplication and we have addition. Multiplication comes first in the order of operations, so 3 times 5 is 15 plus 5 is 20. So both sides of your solution is 20 equals 20. That is a true statement, so therefore it is a solution. If we checked 10, if x equals 10 is a solution, so we substitute in 10. 3 times 10 is 30, plus 5 is 35. 35 does not equal 20, so 10 is not a solution. So to solve a basic two-step equation, you have to do the main goal. The main goal is always to isolate the variable. And remember, to isolate means to get by itself. So we want to get that variable, that x, by itself. So to start, you want to start by eliminating what is furthest from the variable, but still on the same side of the equal sign. So if we're looking at what is furthest from the variable, on the same side of the variable, we have 2 and 3. 2 is touching the variable, it's directly next to it, and 3 is separated from it by a plus sign. So we want to get rid of the 3 first. To get rid of the 3, we have to do the opposite. So plus 3, the opposite of plus is minus. So we want to subtract 3 from both sides. Remember, the property of equality says what you do to one side, you do another side of the equation. You can almost think of an equation like a t-chart. You have to do the same thing on both sides of that line, otherwise it's not going to continue to keep the equation equal. So when we do this, I have 2x. I didn't do anything with the 2x, so I can bring that down. And then the plus 3 minus 3, they cancel each other out because 3 minus 3 is 0. Then over here on the right hand side, I have 13 minus 3, which gives me 10. And then I can carry down my equal sign. So now I have a regular one-step equation. 2 times x equals 10. To get rid of the 2, so the x is truly isolated, we have to do the opposite of times, which is divide. So I want to set up my division so it looks like a fraction, and then I want to divide by the number I want to get rid of, which is 2. So then these two 2's cancel out. I'm left with x, and then 10 divided by 2 is 5. So x is equal to 5. Now, with those properties that we learned earlier, you can use those to justify your solutions for each step that you did. So justification process will look like what you'll see here on this page. So you still have the work, the same as what we did before, but you are identifying the reason and the purpose for being able to do each step that you did. So the first thing we did when solving that equation is we subtracted 3 from both sides. So the property that let us subtract 3 from both sides and still keep our equation equal is the subtraction property of equality. And then why did we do it? Again, our goal is to isolate the variable. For the beginning stages of equations, the reasoning is always going to be to isolate the variable. The property may be different in terms of being some form of the property of equality, but the reasoning is always going to be to isolate the variable. So take a look at the second step. The second step we took was we divided each side by 2. That would give us then the division property of equality, still a property of equality, but the division property of equality. And then again, the goal is to isolate the variable. And then the last thing we had there was x equals 5, which is the solution to the equation. So in order to solve this equation, the first thing we'd have to do is consider it to have that line down the center again. And then we have to get rid of the number that is on the same side as the variable, but the furthest away from the variable. So that's the 2. So the opposite of plus 2 is minus 2. So subtract 2 from both sides. 2 minus 2 is 0, so those two things cancel each other out. I'm still left with the x over 3. I have my equal sign, and then on the right, 12 minus 2 is 10. The next thing I want to do is get rid of the 3 so the x is isolated, because that is our goal. So to get rid of divided by 3, I have to do the opposite, which is multiply by 3. However, the x is not the multiplication symbol in algebra any longer because it can get confused with the x as the variable. So to set up multiplication in an equation, you want to use the parenthesis. So we're putting both sides of the equation in the parenthesis, and then we're multiplying both sides by the number we want to get rid of, which is the 3. So these two 3's cancel each other out, and I'm left with x. And then 10 times 3 is 30, so x is equal to 30. We now have the same solutions that we just did, except now it has justification. So if you're asked to justify your equation, again, remember it's the sum form of the property of equality so far, and then your reasoning is still to isolate your variable. So the first thing we did was subtract. So we subtracted 2 from each side, so that's the subtraction property of equality to isolate the variable. The next thing we did was multiply each side by 3, so that's the multiplication property of equality, again, to isolate the variable, and then the x equals 30 is our solution. The last thing we're looking at with the basic equation is how to take a word problem and write and solve it as an equation. So here we have the word problem. Parking garage charges $3 plus $1.50 for each hour. You have $12 to spend for parking. Write and solve an equation to find the number of hours that you can park. Okay, so the verbal model. Verbal means words. So we're writing our equation out in words. Sometimes I find it helps that if you write the mathematical equation first and then go back in and write the verbal model. Sometimes I think that helps because my brain thinks more mathematically. But either way, to find the total cost of how much it would cost you to go to the park, to park in the parking garage, you'd have to pay the fee to park, and you would also have to pay the amount for every hour that you park. So if we're paying $1.50 for each hour, in order to figure out how much it would cost for multiple hours, you would have to multiply that $1.50 or that cost per hour by the number of hours that you were there. So my verbal model is what I'm paying for is the parking fee plus, because I also have to pay for the cost per hour times the number of hours that I'm there, and then that is equal to the total cost. Then the labels. Labels are what all of those things in that verbal model stand for. So the parking fee is $3. The cost per hour is $1.50. The number of hours is X because that is what we don't know. That is what we're trying to find, how many hours we can park there. And the total cost is 12. So the algebraic model is the equation. So I would have 3 plus $1.50 times X equals 12. To solve it, we would get rid of the thing that's furthest away from the X, but still on the same side, which is the 3. The opposite of plus 3 is minus 3. So I would have subtracted 3 from both sides. I would have then been left with $1.50 times X is equal to 9 because 12 minus 3 is 9. Then to get rid of the times $1.50, I'd have to divide both sides by $1.50. The $2.50s on the left would cancel out, leaving X alone or isolated. And then on the other side, 9 divided by $1.50 would be 6. So that means then, as our final answer, is not just X equals 6 because you need to answer the question. And the question is, how many hours can you park? So my answer is, I can park for 6 hours.